Okay, this video is for Integrated 3. This is your inverses essential skill video. It's the first one for second semester. Here I've got a list of the things that you need to know how to do. So we've already started off with writing the inverse of a function, so the whole idea of using one of the three methods that I taught in class. Again, you choose the method that makes the most sense to you. Also, the idea of restricting the domain to guarantee that the inverse is a function. You want to make sure that when you graph the original function and you graph the inverse, that all of the original function, when it is reflected over the line, over the line y equals x, matches up perfectly with the inverse function. And think about what you're allowed to restrict and what you're not allowed to restrict. I'm going to be able to graph the inverse of a given function. So given the graph of a function, how do you find the lattice points and then reverse those guys? And then we need to prove that functions are inverses. So let's move on to the next page here. So what we're going to do is we're going to find the inverse of the function. We want to restrict the domain if necessary. So at this point, you need to decide which of the methods that you would prefer to do. So for this first example, I'm going to go ahead and do all three methods, and I'm actually probably going to combine a couple of them. And then notice that the answer is always the same at the end. It doesn't really matter. So if I take a look at this, I'm going to have a cubic. A cubic, when I do the inverse of it, is still going to be a function for the time being. In future classes, you may have to restrict, but they may give you the domain to chop it off at. So one of the things that you could do, first method, or I guess it doesn't matter what numbered method is the idea of swap and solve. So what we could do is wherever you see a y in the equation, so our f of x, whoa, that's super dark. Let's do this. Our f of x here is just a fancy name for y, as we know. So if I do swap and solve, everywhere I see a y, I would plug in an x, and everywhere I see an x, I would plug in a y. So from here, now you're going to swap. That's the first part. Now you're going to solve. You're going to solve for y. So in this case, I'm going to have to add the 7 to the other side. Those are going to cancel. That's going to give me x plus 7 is equal to y cubed. Then I need to be able to get rid of the cubed. Well, to do that, I'm going to cube root. So I would cube root both sides. And in doing so, the cube and the cube root on the right-hand side are going to cancel. Remember that you're going to drop the symbol as well. So that's going to disappear. And we'll end up with just a y. I'll put the little 3 into the crease itself, and then we have y is equal to the cube root of x plus 7. When we think about restricting, we, in this class, focus on the relationship between the parabola and the square root function. With the cubic, we're going to be fine. Only other thing that we need to do is go back and rename this using the function notation. So originally the y value was called f of x, so now this is going to be f inverse of x. Go ahead and copy down the rest of the problem that we got. So that is one of our answers, or one of the ways that this answer could look. So f inverse is equal to the cube root of x plus 7. So another way that you could do this, and it's kind of like this. Now the second and the third ones are similar. You can actually think about plugging a number in for x. So hypothetically speaking, we could do f of 2. So this is just a dummy. And I just want to think about what's actually happening to the 2 with the order of operations. Now, the first thing that I would do is actually do the cubed itself. So the first thing that I would do, and I'm going to list my operations, is I'm going to do a cubed. So the 2 cubed is going to turn into an 8, and then I have to do the minus 7. So the next thing I would do is subtract the 7. Those are the order in which I would put operations onto the x value if I plugged it in. Now from here, I am going to reverse the order of the operations, and I'm also going to invert the operations. So I'm going to start with my function here. So I'll do f inverse of x, put an equal sign, and then in my class I call it a floating x. So I leave a little bit of space all the way around it, in front of it, above, below, behind. So I'm not totally sure what I'm going to put around it yet. And I am going to go back to the operations that I did here. So minus 7 occurred. So the first thing I'm going to do is plus 7. So I'm going in reverse order, and I am doing the inverse of the operations. Now, every other operation I do after this is going to affect everything that has happened so far. If I do a cubed, then the next thing I would do is a cube root. So I go back to this whole thing, and I'm going to cube root the whole thing. Notice that my answers are exactly the same, regardless of which method I choose to use. The other thing that I showed in class was like plugging in a number for f of x. Now again, the number that I'm plugging in is just kind of a dummy. It doesn't really matter what it is. It's simply the operation that I'm looking for. So let's say I plug in a 9 for my f of x. Again, just a number that I'm plugging in. Oh, I believe that's a minus. And I'm copying down the original question. So notice I plugged a 9 in for f of x this time. So if I bring over my f of x equation, just plugged in a number. Now from here, I'm going to go ahead and start building my equation. So I'll take out my f inverse of x. Whatever I do up to my dummy equation is exactly what I'm going to do here. So I put an x, kind of a floating x with stuff around it. I know that to solve this, I would add 7 to both sides. So I'm going to add 7 to both sides, exactly what I would do. And I would get, I don't know, some number. Doesn't really matter what it is. To get rid of the cubed, I would cube root. So I'm going to cube root. Notice again that my answers are exactly the same. So it doesn't really matter what you choose to do as your method. That is still going to give you the exact same result. So moving on to the next slide, we have a different example here. Notice this original equation is a line, and as long as the line has a slope other than undefined, it is going to pass the vertical line test, so it is a function, so I can call it g of x. So what I would like you to do at this time is I want you to pause the video. You decide which of the 3 methods on the previous screen make the most sense to you, or what methods you have used in the past, or what you have used with Ms. Hodge in her class. So at this point, pause the video. I'm going to go ahead and work it out, and then I'll put the answer here for you so you can check. So here I've worked it out all 3 of the ways, following the order on the previous. So I did swap and solve. I wanted to show my work so that you could check your answers and your work. Although understand, work isn't necessary to show here. This scratch work above the inverse answers is work for you. So in this case, I end up with the exact same thing regardless of which method I choose. Notice that the inverse is the graph of a line, and as we discussed in class, when you find the inverse of a line, assuming there are no restrictions, so it's not a line segment, then all of the original graph is going to match up with all of the inverse. Again, the only thing you have to watch out for are vertical lines, those aren't functions, so just be careful with those. Okay, we have another example here. However, this one is a parabola, which means beware immediately. We know that a function parabola, so parabola that opens up or down, y equals parabola itself, is going to have the inverse of a square root. But we want the square root to be a function. So we don't put the plus or minus in front of the square root. What we do is we actually limit the parabola itself. What we're going to do is we're going to limit the parabola at the h value. So the first thing that you need to do, knowing that the inverse of this is going to be a parabola, is figure out what your h value is here. So in this case, for your hk, not to be confused with the name of the function, the h value is 6. So what we're going to do immediately is you restrict the parabola, put the restriction on that equation, don't worry about the square root function restriction. Put a comma at the end of this guy. I'm going to restrict the x value at the vertex. Typically, people like to choose the right-hand side, so then you have a positive square root. So I'm going to go to the right, but I do want to keep the vertex itself, so greater than or equal to 6. Once I have done that restriction, now I proceed the exact same way that I did on the previous problems. So again, great opportunity to pause here, work out how to find the inverse like we did on the previous two screens. Choose the method that makes the most sense to you and then come back and check. Okay, so now here I've got my answers. You'll notice that regardless of the method that I chose to use, I get the exact same answer. But in addition to that, so these are your answers. Again, you don't have to do all three of these methods. Choose the method that makes the most sense to you. But keep in mind, too, that part of the answer is the restriction on the original parabola. Also, since I chose, this represents the right side because of the greater than part. You'll notice that in front of my square roots, every single one of them, that's a positive sign. That represents the right-hand side as well. Now, if I wanted to keep the left-hand side, then I would have put a negative sign in front of my square root, and I would have flipped the inequality symbol. Okay, moving on to the next slide. Still the same type of problem. Notice, though, that you're starting with a square root this time. If you're starting with a square root, remember, parabolas and square roots partner up. So, again, take this time to pause the video, find the inverse using your chosen method, but then take a look at that inverse. You need to make sure that all of the original graph and all of the inverse match up together. So again, be careful. Okay, so I went through all three methods, as you can see here, and I got the exact same answer on all of them. I am a little concerned because I did get a parabola, so I think I still need to restrict this thing. So there's that answer, and they match, and they all match. However, if I went through and I graphed this parabola and I compared it to the original function that was given to me, and I reflected it over the line y equals x, I would have too much parabola, ultimately. So I'm going to cut half of it off. Go back up to the original problem, and you want to look and see what kind of a number is in front of the square root symbol. Now it's a 2. Okay. I want to look at the sign, though. Notice that the sign here that's given to us is positive. So notice that the number in front of this is a positive number. That dictates that I'm going to be keeping the right-hand side of the parabola. So if I go back down to my equations, I want to find out, so I'm going to put a comma here, I'm going to find the right-hand side, so greater than or equal to my h value. Well, if you take a look at the equation, my h value is right there, but remember it's x minus h. So I think we're just going to have 3. So regardless of which method you chose, at the end you're going to need to include your restriction of x greater than or equal to 3. So let's make sure that those guys get highlighted as part of the answer as well. So you're going to make sure that you include the restriction in your answer. Okay, so now we're moving on to something else. So we have a graph here, and we need to be able to find the inverse of the function. So we're going to find the inverse, but then we also have to state whether or not the inverse is a function. So in order to do this, I'm going to go through and I'm going to identify some of the points here. So I was already given some of the endpoints, and I'm going to assume that these increments are by 1. So it looks like my first point I'm going to have is -4, 1. And what I'm going to do, and this wasn't given a name, so I'm going to call it f of x. It is a function because it passes the vertical line test. So let's go ahead and call this guy f of x. And so I'm going to make the table over here. So f of x, and I'm just going to start writing down the points that I've got. So the first one that I have there is -4, 1. And I'll go back and find the inverse in just a minute. But I want to find more lattice points. So any points that look like they cross it like a grid. So if I do -3, that looks like a lattice point to me also. So let's do -3, 3. So I'll go ahead and write that as well. And then I'm just going to go across the graph. Looks like this one's pretty close, so I'll take that one. So 1, 2, 3, 4. So negative 2 comma 4. And I'm just going to train across the rest of the graph and try to find lattice points. Definitely not at negative 1, that's partway through. But at 0, that looks pretty good. So 1, 2, 3, 4, 5. So at 0 comma 5. So again, I'm just trying to find nice points. Not at 1, it's close but not perfect. 2 looks pretty good though. So at 2 comma 3, I'm going to go ahead and just identify the points. And then not again, I mean it's kind of close here, kind of. So I'm going to go ahead and use that one also. So let's do, what's that, 1, 2, 3, 4 comma 0. And then my very last point that was given to me, which was 5 comma negative 1. All right, now to find the inverse, what I'm going to do, and I'm not going to call it f inverse of x yet because I don't really know what's happening here. I'm just going to take all of these points and I'm going to flip them around. So the x and the y swap places. I'm just going to record all of those. X and y swap places. These are going to be my new points for my inverse graph. And then after recording them, I'm going to go ahead and plot those points. So go ahead and pause for a moment. I'm going to go ahead and plot the points. Okay, after you've after you've plotted the new points, you want, if it were me, I normally take my paper and I turn it sideways. So it looks like I'm still graphing from left to right on the x-axis. So you want to connect the points either from bottom to top or top to bottom. You don't necessarily want to go left to right here on the inverse. Think about actually rotating your paper. So if I were to trace this, and I do want it to look like it's been reflected. So I'm going to go ahead and plot and graph these points here. And that kind of got me up to my point here. And then curved down, and then it looks like it twisted a little bit. So that if I were to go through and graph the line, the y equals x, let's see if this will fit here pretty good. I want it to look like it's been reflected over that guy. There we go. So now you can see that if you fold over the line y equals x, it looks like the black graph and the green graph line up with each other. Now, I still have to answer the question, is the inverse a function? No, absolutely not. So I would say the inverse is not a function. Since it fails the vertical line test. So back here in my table, I wouldn't call this f inverse of x. I would just call it the inverse. So on my graph, if I were to label this graph, I would say that this is the inverse of f of x. I would not call it f inverse of x. Can't use the function notation on it since it's not a function. Okay, moving on to now proving inverses. So if we take a look at this, if I tell you, and I will, if I say to prove that the functions are inverses, it works. I promise. Guaranteed. You may have to do some restriction of your domain, but the algebraic manipulation of this will be accurate. So it's going to work, I promise. All right, so I'm going to do what I did in class. I'm going to set up a table, but before I do that, I'm going to take a look at my original problems here because I see a parabola. If I see a parabola, I know I'm going to have to restrict. So I take a look at the very beginning of the square root function here. That is a positive number. And since it is positive, and this little green note is kind of just for me, then I know that I'm going to keep the right-hand side. So I'm going to go back over here, and I'm going to keep the right-hand side, and it's the h value, or the x value of the vertex. In this case, there's nothing being added or subtracted to the x, so it's going to be greater than or equal to 0. Okay, now I'm ready. So I like to set up an organized table for myself. So I'm just going to go ahead and set up an organized table here. On half of it, I'm going to do f of g of x. On the other half of it, I'm going to do g of f of x. So let's do f of g of x first. Okay, so here's what this means. I am going to take the inside function, this g function, and I'm going to plug it into the f function. So first thing I'm going to do, I'm just going to start writing the f function. So I'll have my 5, and then wherever I run into an x, I'm just going to put a big hole there. And then finish writing the f function. So basically this should look like the f function with the x kind of ripped out. Now, in the x's place, I'm going to put all of the g function. Be careful that your fraction bars go as long as they're supposed to, and that your roots go as far down as they're supposed to, but not too far. Just be careful. Now, you are allowed to do one step at a time, no more than that. So if you find yourself madly crossing things off, more than a pair of things, we've got problems. One thing at a time. After one thing has occurred, you're going to rewrite what you have left. So in this case, as I follow this along, I'm going to cross off things that look like they're actually physically closer to each other, and I'm going to make sure that our order of operations actually supports that. So in this case, I can't get the 5s because there's a root in the way, and parentheses, and a squared. Same thing with the 7. So the square and the square root are going to have to go. So get rid of the square, get rid of the square root. Remember that the symbol disappears. But I think I still need the parentheses. So I'm going to drop the 5 that was there. The root is now gone. And I'm just going to copy everything else down. Again, follow order of operations. I can't get to the 7s yet because the 5s are in the way. In addition to that, there's parentheses. So the 5s are going to go. Now, I only needed the parentheses because of that 5 just a minute ago, so I can dump that. Now, the 7s are the last things to go, and I end up with x, which is exactly what I expected to end up with. Now, I got to go the other way. So, in order to prove this, you have to prove both g of f of x and f of g of x. They're both required, and they must both equal x. Okay, so I'm going to take the inside function, I'm going to cram it into the outside function. So start writing the g function. And then everywhere you see an x, just leave a big hole for it. So there's my x, and then I have a plus 7 all over 4. Making sure that the root went down as far as it's supposed to, and my root isn't quite as far across as I want, so I went ahead and extended it. Now, inside, I'm going to cram the f function in there. So I'll do 5x squared minus 7. Now, you'll notice this time the parentheses weren't necessary. So if the parentheses aren't necessary, then you can go ahead and erase them. If you think that they're helpful, leave them there for yourself. But I'm going to go ahead and erase these guys because I don't think I need them. And actually, it might confuse me if I keep them. Okay, so now if I take a look at this, the only thing that I can do now is the 7s. So let's get rid of the 7s, rewrite exactly what you have left over, Looks like I have a 5 squared on top, 5x squared on top, and a 5. I cannot get rid of the square and the square root yet because the 5s are still causing problems. So get rid of the 5s. Now I have the square root of x squared. Now I can cancel the square and the square root, and it looks like I get x. So it looks like my table was a little bit bigger than I needed it to be, so I can go ahead and erase part of the edges of it. And you're almost done. Remember that we want the value that was inside the parentheses here. So the x, remember we use a generic x because it's as if we were plugging in every single number that exists on these graphs. We want that value x, that generic value x, to be the results that we get out. If you get out anything other than the x that you plugged in the first place, so the generic x, then you made a mistake somewhere in the process. Either that or the direction said determine if they're inverses. Okay, so in this case, they are. Last thing we need to do, we got to write our statement. So I'm going to say since f of g of x is equal to x, so that was the first one we did, and the other one, g of f of x is equal to x, so both of them, then we can say the original functions f of x and g of x are inverses. That whole thing, table, the identification of the f of g of x and the g of f of x, going through and showing every single step and then writing our final statement at the end, that is the proof for this problem. And then we have one more problem here to do. If it were me, I would pause the video right now. So pause the video, see if you can prove that the two functions are inverses of each other. Remember, the directions do say prove, which means it's going to work. Take a look at these original functions. Oh, looks like we have a mistake here. So I apologize for the typo. Let me fix that. This is going to be a cubed, not a squared. So if we take a look at this, we know that this is going to work. Go ahead, slowly, see if you can prove. Okay, now this one required a few more steps, but please take this moment to make sure that your f of g of x and your g of f of x match mine. You'll notice that I made sure to use either brackets or parentheses when I plugged the other function into the original. I also only completed one operation at a time, making sure that my roots dipped as low as they were supposed to and my fraction bars went as far as they were supposed to. Don't forget to have your statement at the very end. Remember, if you have any questions, come see me before the test.